Okay, hello, welcome to my channel. Now in this video, we want to solve this definite integral question from the JEE Main math question. So we are given that f of x should be a function satisfying this equation here, where we say the equation means that f of x should be the same thing as its derivative, with initial condition f evaluated as 0 equals to 1. And g of x should be a function which satisfies this equation, that the sum of g of x and f of x should give us x squared. Then the value of this integral from 0 to 1 of their product should be this, right, where a, b, and c are unknown constants. So we are asked to find the sum a plus 2b plus 2c. Okay, great. So we have to first of all find find the function f and then the function g, okay, in terms of x for both of them. And then after evaluating, multiply them together, and then we evaluate this integral, which will get the result. And then from there we get a, b, and c, which we can compute this sum right here. So in fact, let's just get on with it real quick. So the first equation we want to start off with will be this equation, which will help us to find the function f of x, right? So let's see what we have. So we have f of x to be f prime of x, right? In fact, this right here is a differential equation, right, where the function is the same thing as its derivative. And this tells us about the exponential function, because that's how the function behaves. Okay, great. Now, this is what we have. Well, from here, we can just divide both sides by f and then multiply dx on both sides, given that f prime of x can be rewritten as, let's see, f prime of x can be written as the derivative of f of x with respect to x, right? Great. So if we divide both sides by f of x and then multiply the dx on both sides, what we're going to have is that 1 over f of x times dx, the f of x should be dx. Okay, so we just multiply dx on both sides and then divide f of x on both sides, and that's what you're going to have. Okay, great. So the next thing I'd like to do here is to go ahead and integrate both sides, all right? Given that, yeah, we can do that without any problems. And when we do that, remember to always add an arbitrary constant, okay? So this means we are going to have, well, we want to find the integral of this function. So we have 1 over f of x. Well, this is an unknown function. How can we integrate it, right? But keep in mind, this right here is not just dx. Rather, that there is f of x as well. So it's just like having the integral, let's say, sorry, just like having the integral of 1 over t dt, right? So 1 over t dt. So here is t and here is t, right? While here is at top is 1. And of course, we know this to be the natural logarithm of t, motivated from the fact that if the derivative of a denominator gives us the numerator, then the integral of that fraction will just give us the natural logarithm of the denominator. So we are going to do the same thing right here, which will give us the natural logarithm of the denominator, which is f of x. Okay, great. And in fact, we want our function to be defined. Yeah. Anyway, let's just keep it like this and then see what we have. Well, this is going to be the integral of 1 dx, right? Or that is with respect to x, which will just give us x, of course. And then remember to always add the arbitrary constant. And in fact, since we have c already here, let me just use d. Let's not mix things up, right? But it doesn't matter, it will still change with time. Okay, let's just call that d1, d1. Now, since we're trying to find our function f of x, right, we will try to recover f of x here by trying to make it stand alone on one side, and we can do that by making e the base of both sides. So maybe I will do that, make this e the base, and then e the base here. All right, this now becomes the natural exponential function. So you notice this power here will be shared, or e will be the base of those two so of the sum there, right? Okay, so let's see what we have. Well, when you take e raised to the power of the natural logarithm of something, in fact, we are just going to get the entry, that is that thing here, because these two are inverses of each other, and their composition will produce whatever we have inside here. So this means this is going to become, what do we have inside the f of x, right? To be, well, we are going to share, you know, this is a sum of powers. So when you have a single base raised to the sum of two powers, we can split it this way. We can say e raised to the power of the base, the power here, times e raised to the power of x, right? And I'm putting this in red because you notice that d here is an arbitrary constant, and saying e, which is a constant on its own raised to an arbitrary constant, the result is going to be an arbitrary constant. So maybe we can call that, maybe let's call it r, right? So that means that this function f of x is going to be, let's call this r, right, times e raised to the power of x. So you notice where r here is in fact e raised to the power of d1, which that is an arbitrary constant. Okay, so we have our function x, right, f of x, right? Okay, very nice. But you notice that we were given an initial condition which tells us that f evaluated at 0 should be 1. So what that means is that when x is 0, the value of a function should be 1. So in fact, I'm going to make use of that right here by looking at our function. If evaluated at 0 in place of x, right, the answer is said to be 1. So, but the answer here is said to be r e to the power x. So we are going to equate this to r times e raised to the power of x, where x is going to be 0 here. Good. So what that tells us is that e raised to the power of 0 is just 1, right? So r equals to 1. That tells us that our arbitrary constant r is in fact 1. Okay? Alright, so since the arbitrary constant is 1, what does that tell us about our actual function f of x? Well, the f of x will now become, in place of r, we are going to put in 1 because that's what r is, right? So that's going to be 1 times e to the power x. In fact, our function is in fact e to the power x. So the essence of this arbitrary constant, initial condition, is to help us to evaluate to get the value of the arbitrary constant. And when we've gotten that, we now get the actual function, okay, that satisfies this equation right here, following that initial condition. So when you get your function with the arbitrary constant, plug in the initial condition, right? If you have like 2 or 3 arbitrary constants, depending on the order of the differential equation that was given, then you would also have as many initial conditions as possible, just to make sure that you evaluate all your arbitrary constants. So we've gotten our r to be 1 from the initial condition, and substituting 1 in place of r here, we have our particular function, which is e to the power x. Good. So that is the function, that is the f of x, right? It's said to be what? E to the power of x. Now we have another equation here which tells us that the sum of f of x and g of x is going to be x squared. And since we've gotten f of x to be e to the power x, that means g of x will be, the difference of x squared and e to the power x. Alright, and when we've gotten those two functions now, we can now multiply them together and then find the value of that integral, right? And in fact, we are all ready to finish this off. So let's just clean this part of the board, keeping in mind that our function f of x, maybe let me put it down here, keeping in mind that f of x is just e to the power of x. Okay, so let's just clean this part and continue. Okay, so since we've gotten our f of x to be e to the power x, that tells us that g of x, let me put it down here, f of x is e to the power x, alright? That tells us that g of x will be, well, that will be x squared minus e to the power of x, right? Okay, that's the crazy looking function. The difference between an exponential function and a logarithmic function. Well, but two of them produced non-negative results. Okay, that makes sense. Let's see. Now we have to find their product so that we can put them inside this thing here. All right. In my building up of the question, I forgot to put a dx here. Maybe it was just my mistake. So let's just put, since they both have a variable, we should be integrating over that variable. Or maybe we should define a variable we are integrating over so that we know if we should even do some work or not. So sorry, this was an oversight. Okay, so let's see what we have. So the value of this integral, before we get there, let's find the product, all right? That is f of g times the g of x. F of x times g of x to be, well, we multiply this and that together, we're going to have x squared times e to the power of x, right, minus e to the power of 2x. Okay, so we've gotten the product of those two functions. So we are now ready to evaluate this integral. So let's see. We have the integral from 0 to 1 of the product, which the product of those two functions is this. It is x squared e to the power x minus e to the power of 2x, right? And then we can just put the dx over here. You don't forget the dx. Okay. Very nice, isn't it? So let's see, and this in fact is a very simple thing to deal with. We can split this integral, right, given that the integral of the difference of two functions is the difference of the integral of those two functions. So maybe I can rewrite this as the integral of this part, right? Let me just split this thing at once. The integral of this part over the x variable minus the integral from 0 to 1 of the second part, which is e to the power 2x over the x variable, right? This negative sign is from the difference between those two functions. All right, so we notice here that in this part we are just going to use the DI method, right? Or integration by part. We're going to use integration by part, which I can use the DI method to handle that. I'll just set this up, minus, plus, and so on and so on. You can continue as much as you want. Okay, very nice. Now let's see. We are going to put in a function we want to differentiate and a function we want to integrate. So of course, we want to differentiate the x squared since the derivative will keep on reducing the power, and then we'll just integrate the e to the power x. It's not hard to integrate, and this one doesn't change, right? So you notice that the derivative of x squared will just be 2x. Now, if we were integrating x squared, we will be building up the powers, which means it will make the work even more complicated. So in fact, you always choose to differentiate this term right here. Okay, maybe we are not going to end here. Let's just keep on alternating. You can alternate your signs as much as you want. So if we differentiate this again, we're going to have just 2. We differentiate 2, we're going to have 0. Well, when you integrate the exponential function, it stays the same throughout, right? Stays the same, just the exponential function of x, the natural exponential function. Okay, so when we are done like that, what we do is to multiply this and that together diagonally, right? Multiply this and that together, multiply this and that together. Okay, so this means this will become, this right here will become, well, let's see, that will be x squared times e to the power of x. Multiply this and that together. Always pay attention to the sign in front at the same time. That will be minus 2x e to the power of x, right? Multiply this and that together. We have plus 2 times e to the power of x. So we are done with the integral of that. But remember, we have to do that from 0 to 1. So in fact, I'll put this from 0 to 1. But that's not all, because we have another part here to look at. In fact, we can do a u sub right here by saying let u be this numerator, then you do some differentiation and that. Okay, let me just show you all the work real quick. So let's say let u be the power, which is just 2x, right? Now, what does that tell us? That tells us that if we differentiate u, we're going to have du to be, well, the derivative of 2x with respect to x will just give us 2, and we put the dx behind of it. Good. So you notice that here we can multiply this by 2 and then divide the 2. Just by multiplication by 1. So you notice that 2 dx can be called du, and then this next thing we'd like to look at is the boundary conditions, or sorry, not the boundary conditions, the boundary of the integral. Well, since we are doing that with respect to x, when x is 0, what will u be? Well, when x is 0, you notice that u will be 0. When x is 1, u will be 2. So you are no longer integrating from 0 to 1, rather we will be integrating from 0 to 2, and pay attention to the negative in front. So we're going to have 1/2 of the integral from 0 to 2 of e raised to the power of, well, in place of 2x we are going to put in u, right? Great. And then we have the dx over here, which we can call, we have 2 times dx over here, which we can call du. Now you notice that the integral of the exponential function with respect to u, which is just in simplest form, is going to be e to the power u, okay, and then we are taking that from 0 to 2. All right, so as always, we are going to maybe put this down here. Remember the negative sign, okay? Remember the negative sign, and we put the 1/2 of e to the power of u from 0 to 2. Okay, let's just finish this off right here. So as always, we are going to put this in place of x and then substitute 0 as well. So you notice when we substitute 1, we are going to have, well, 1 here, that will just be e, all right? When we substitute 1 here, we're going to have minus 2 times e, all right? And then we substitute 1 here, we're going to have plus 2e. Then we're going to say minus, we substitute 0 into all these terms as well. This minus, keep in mind, is from the difference, this and that, right? So when we substitute this, we're going to have, well, 0 in place of x, this term will be 0, this term will be 0, and then this term will just be 2. Since this is positive 2, we will put the minus and then the 2, right? Okay, very nice. So this term, this here is from the 1, and then this one is here from the 0, and then we say minus 1 half of. Well, you notice when we substitute 2 in place of u, we are going to have e raised to the power of u, right? And then we say minus, we substitute 0, we're just going to have 1. Sorry, this will be e to the power 2. Okay, that's very nice. Now let's see. Let me clean this part of the board, and then here we will continue from here and then find the final part of the solution. Okay, so as you can see, this right here is from this part, right? So just the same thing. So I'm going to clean this off. All right, but let's see what we have here. Well, you notice that this and that are in fact negative of each other. Okay, so we can just make them become 0. Then we are going to be left with just e to minus 2 here. Then minus 1 half of. Well, notice this is e to the power 2, right? So we just split this to everybody inside. We're going to have e to the power 2 minus, well, this times that will just be positive 1 half, right? Okay, so we can combine some terms, and we're going to have, let's see, e minus 1 half of e squared. We're going to have negative of that will be negative 3 halves, right? This right here is very nice. And now let's see, from here we can compare this with that, all right? Since we are done integrating, you notice that a is going to be 1, right? That is the coefficient of e here. Then we have b, which b is the coefficient of, we have b to be a coefficient of e squared. So the coefficient of e squared here is just negative 1 half. That's our b. And then finally we have negative c. Well, we have negative 3 halves. So in fact, c is 3 halves. So you take note of your signs in front. This was just a plus b in the given general solution, in the general integral. But here we are having negative 1 half. So in fact, b must be the whole negative with the 1 half. But here we are having negative c here, and also we have negative 3 halves. So in fact, c must be 3 halves alone. So given this, you can compute what was required, which is to add a to 2b plus 2c. So you're going to have a, you're going to multiply this by 2 and then multiply this by 2 and add all of them. And when you get, your result should be, maybe you compare this with your own answer, that will be 1 minus 1 plus 3, right? The answer should be 3. Let's just see. 1 minus, 2 times 1 half will just be 1, together with the negative sign. Then you have plus, well, 2 times 3 halves will just be 3. So the answer is in fact 3. All right. So you check that out. Okay, I hope this was helpful. Thanks for watching, and please do us to subscribe to my channel. Let me know what you think, and also maybe other JEE Main integral questions from you, definite integral questions, right? Okay, thanks for watching, and please share this video with your friends.